do a half an hour presentation and then some questions, and then I go and sit with my committee, which is Dr. Luberstedt and Dr. Fay, and they'll ask me some questions. But he said, plan on about 2 hours for the whole thing, and I'm like, yeesh.
Okay.
Is this going to be a big deal or not?
I watched a couple, like 2 weeks ago now, maybe a month ago, and it seemed pretty laid back during the PowerPoint side of things, but then it was me and a couple other guys that were listening on Zoom, and then they had us log off in order for them to talk to the presenter, directly without anybody else listening.
Yep.
So I'd be curious to know, like, kind of what that type of conversation is.
Yeah, one of my coworkers did this, but he was in the agronomy side, and he said that after the presentation was done, and I saw that, so I know kind of what to expect. He said he just went into another room, the back room with his committee, and they talked with him for like 10 minutes, and then he was done.
Oh, nice.
I'm not sure if that's normal.
Gotcha.
So, Dr. Luberstedt did say that once you're accepted to come down and present, and once your creative component or whatever is accepted, it's pretty much a done deal.
Gotcha.
So, I have no experience otherwise to know. If anybody else has any ideas or things they want to throw out, go ahead.
How many revisions did you have to go through?
3.
Okay.
So the first one, and they kind of took it by chunks. I kind of liked it. So Dr. Fay did like the introduction, and then the material and methods, and then Dr. Luberstedt did the discussion, and then Dr. Fay did the results and the discussion, and then Dr. Fay did the conclusion and the I can't remember the other part, the one you put right at the very beginning, the abstract.
Yeah.
Yeah, and then I had to I'd readdress a lot, and then the whole thing overall. So, but my biggest problem I noticed is that I come from doing a lot of presentations, so I worded it and wrote it that way, which was not very scientific, if you will.
Sure.
So once I kind of turned my brain into that, I did like a major revision. That helped a lot.
Gotcha. So since I haven't really started this at all, and I'm hoping to graduate in August, do you think that's possible if I take that $5.99 course this summer?
Oh yeah,
that's plenty of time.
Yeah. I'd say it depends mostly on who your committee members are.
Okay.
I don't see why you couldn't.
Gotcha. Because this is it for me.
I hear you. I'm glad that I'm going to be done.
Yep.
I keep telling myself once next Wednesday is done, then at least I have the huge portion done, and I just have to pass this class and my other class.
Right.
It's always possible to trip up at the last moment, though, right?
Nah, you got it. You're in the home stretch.
I hope so, man. I really do.
You have any plans for the summer?
Not die. Recover.
That's good.
What normal life is like again.
Yeah.
We've got I know you guys know about this. We've got our foreign exchange student. He leaves on June 10th, so we're going to go camping up on the north shore of Lake Superior, like the week before he leaves. So doing part of that and just
awesome.
And then my boss is having me present down at the ASA, SSA, CSA, whatever meetings in November down in San Antonio. If you're familiar with them, so I've got to get all summer. I got to work on that, and then this creative component I'm doing, we're going to turn into a paper as well, and try and get it published. So that's kind of the other stuff that we're working on. So you don't quite get to escape it all, I think.
Nice. Well, that's cool. Yeah. Where are you going camping? I think I told you I went to my undergrad degree in Duluth, Minnesota.
Yeah. Well, the only place, we just got our reservations today. The only place that still had anything left for a pull-behind pop-up camper was Gooseberry Falls.
Yeah, that's nice.
Yeah, well, I like going up like Tetagooch or closer to Grand Marais, but you take what you can get.
Sure. Jay Cook's pretty fun too. If you
Oh yeah, that's another good one. Yep, we went there. I think last May, or not last May, but a few years ago in May, and it was the river was really full, so there was lots and lots of whitewater in there.
Oh yeah, sure.
From the rocks, and then there was a massive thunderstorm that went through in the middle of the night. That was kind of fun to sit through.
Cool. So how much earlier before the end of the semester did you turn in your first draft of the thesis or your creative component?
Well, I split it between the 2 semesters. So I did 1 credit in the fall and 2 credits in the spring.
Oh, gotcha.
So because I had 2 classes last fall and 2 classes. My original plan was to take one of these classes last summer. So then I'd have, I can't remember which one it was. I think it was 523. I could have maybe taken last summer or some weird thing like that. And then I would have only had 1 class this spring, and I was going to do my creative component all spring, but I split it. So I had the materials and methods done by Christmas, and then just the real rough skeletal outline of it done. And then over Christmas time and January in particular, I wrote out everything else. I just really dove into it. Now mine's based on my original research and not on other publications.
Sure. Yep.
So that helps. And then nobody's really doing wild race research, so that helps. It's a little obscure.
Gotcha.
So cool. I'd say, knock it out as fast as you can.
Yeah. God, I wish I would have known you could split it up like that. That would have been a good idea.
Yeah, but then you actually have to. You have to go through with your committee, and they have to approve it, and then you have to turn something in for part of it. So,
gotcha.
I hope he didn't forget us tonight.
Starting to look like it.
You posted the lecture late yesterday too. I looked around like 5 o'clock my time and it wasn't up yet.
Well, whatever works. I am actually, while I'm talking, finishing up doing the diploma ceremony portion of this, so it's nice to actually get some of this stuff done.
What's that mean?
Oh, it's will I be attending the ceremony this spring or not? If I am, what's your gown size? How to pronounce your name? Where to send the newspaper release to?
Ah, gotcha. Tyler, are you on? What's new in Syngenta land?
I think that's Tyler's answer right there.
I guess that sums it up, yeah.
So whose computer fried Sunday night? Was that Kyle's?
Yeah, I think it was.
Okay.
Oh no,
You didn't read that in the discussion, huh?
I missed that.
His motherboard went bye-bye. He was saying, do you think they saved my Word document was saved? Poor guy.
Oh.
Oh, got to jump off for a moment. So, in other news, my son just got home. He had his ACTs today, so on the other end of all this mess. You guys remember those days?
Yeah, nice.
So I'm sure he's glad to be done with that too.
Yeah, he looks a lot smilier right now than he did last night. So, anybody want to dive into the homework while we're waiting?
Probably a good use of time.
Yep. Yeah.
Anybody has thoughts on how to answer them?
We start with ALA 14.
Yeah.
Yeah, I like doing them in order. The only thing that makes sense to me.
Okay, a lot of data.
So I mean, question 2 is pretty basic. I can do all that in R, just the standard stuff. So question 1, how did we get enough seed?
Yeah, that's actually a good question because I was going to ask, how would you normally, if anybody has any experience with corn, how would you get enough seed?
Send it to a nursery, but if we're not allowed to do any breeding.
Yeah, exactly. Just says you obtain enough seed for the field trials from 103 of the plants that flowered at the same time as the tester. Can you get? I mean, how many seeds do you have to plant in a plot for corn for it to be useful for evaluation? I mean, one row with 10 plants or what?
I mean, I'm thinking like our standard is like a 17.5-foot plot. But usually we usually take data on 2 rows. So I mean that'd be a minimum of like 65K or so, or 66. But 60 plots is quite a bit.
Yeah. From reading it, it looks like you only have 1 plant. Unless.
Well, you get 500 kernels and cross those that flower at the same time as one of your elite lines. Using the elite line as the tester.
And then it says you obtain enough seed for the field trials from 103 of the plants that flowered at the same time as the tester.
Yep, so that means you could cross them.
And then if you look at the file, you know, there's 105 different sample IDs, 2 of which are the current top hybrids.
Yep. So it's saying we got the seed. It's just a matter of.
That's what, I don't know. You can't get that much seed from 1 plant.
Can you get it from 103 plants? Oh, I see what you're saying. There's 100 and yeah.
Because each of those is put into 6 different.
Well, you'd have to get at least 60 seeds per plant to get 1 plant per field plot.
Yeah. So I don't know if we just say that only a couple seeds are planted at each site, but that just doesn't make sense to do that.
Yeah, no, I mean, I feel like you almost just have to say you produce enough seed, but I feel like he's got it, like it's a trick question.
Yeah. Because it looks like, and the way it's written, I don't think you would have been able to, like, bulk up the seed at all.
Yeah, exactly.
Well, it's actually said right there. It's 6 samples per cooperator. I mean, I don't know field 1, 2, 3, 4, 5, 6. I mean, I don't know what the plot size is, but it's sample 1 is put into with cooperator 1. There's 6. Must be 6 sites. I mean, I'm just kind of running through it. 6 sites in 10 regions. Okay, so each cooperator does
6 blocks within 10 sites.
Well, the yield is 7.
Well, could you do an increase through the winter on those 103 plants?
That's what I was saying. It doesn't really say one way or the other if you're able to do that.
Well, what I'm saying is can you or what can you do with popcorn or corn to the problem is that you basically, if you crossed everything, you just made a whole bunch of F1s. And how do you keep them as F1s?
Well, unless you harvest all of the seed from each of the 103 plants, and then you plant those in rows and self-pollinate all of the plants in each row. But then you would have...
You'd still get segregation.
Yeah.
Yep.
It is an open pollinated population, though.
Hi, everyone. Sorry I'm kind of late tonight.
Hello.
No
Are
worries.
How are things going?
We're already puzzling over question 1 on ALA 14.
Okay.
I don't know popcorn or corn well enough to know how you can get enough seed for 60 field plots.
Yeah.
Yeah, that's something to think about, isn't it?
Yeah.
So an ear of corn will produce kind of, at best, 300 kernels. So you could think of 300 kernels. And if a plot had 100 seeds in it, clearly you can't, it has to do with how you direct your crosses, right?
Yeah, because I don't think
In order to get your test cross seed, right? So you'll have a plant, and there are 103 of them or something. Yeah, 103.
Mm-hmm. Yep.
And so 103 plants. If you take the tester and cross use the tester as the male, you'll get enough seed for 200, right? To represent that one plant from the population. So, maybe you have to do it the other direction.
There aren't any. We shouldn't consider that there might be. I don't know if there are complications from you doing the male to female and then vice versa with popcorn.
Yeah, and that's not going to be the case.
Okay.
Popcorn is like corn. You just collect a bunch of pollen from a popcorn plant, and if you can have a tester, a row of a tester, you can take that one plant and pollinate every plant in that tester. If that tester is an inbred line, you have to sort of be able to do something like that.
So you can cross it both ways and get.
You can cross it both ways, or you don't really need to cross it both ways. If you have a tester where every plant is identical to each other, it's just a matter of planting enough plants. And of course, pollen is not a limiting situation. You share pollen with as many plants as you want to.
So you'd pollinate from I want to make sure I get this, the new land race to the tester, so you can create as much seed as you want. And there aren't any, I don't know corn very well, but there aren't any male cytoplasmic or female cytoplasmic differences regardless of how you pollinate, or we shouldn't consider that?
Yeah, there's no CMS issues here.
Okay. Well, that answers that.
So yeah, it's just some details now as to how many crosses do you need to make using each of these 103 plants as a pollen source.
And 100 seeds per plot is a reasonable amount?
So a field plot, yeah, I don't, I think, what, you'd have to maybe look that up, but I think a typical plot, at density of 30,000 plants per acre translates in something like 110 seeds per plot, where a plot is a 10-foot row or something like that.
Okay. Yeah, we were talking, and some people were saying that for corn it's a double rows, or.
Yeah, it's 2-row plots. Yeah.
2-row plots. Yeah.
A lot of places, in this case here, you don't need to deal with that, but a lot of places use 4-row plots, but only harvest the inside 2.
Mm-hmm, yep.
But that's in a little more advanced trials, not in a preliminary trial.
So well, that's a good question. For a preliminary trial, would you normally do just a single row?
No, a couple of
Still
2-row
do a
plots.
2-row? Okay.
Yeah, right. Good questions, though. So where's Kyle in this group? I don't see Kyle. Normally he or Tyler. Tyler, you would know some of this stuff.
I don't know if Tyler's talking tonight. He may just be recording.
Okay, that might be it. Yeah. All right. Any other questions?
Did you want to have a discussion about the testing at all? I know you sent the
Oh, yeah, I sent out the announcement. Sure. Well, I just set up a poll, and let people vote at the poll. I'm not sure there's much more to be discussed other than, do you want 2 more tests or do you want 1 more test?
I guess I'll just be the one that throws it out there because why not? And which way is going to be the least amount of work?
Yeah. Well, I don't know. I don't know if either will be less work or more.
Yeah. I overheard John's comment at the end of the lecture from yesterday where he's talking about all the presentations he has to do, so he's kind of opting for a single test.
Oh, yeah. No, that was Lyle. Lyle's.
Oh, Lyle. Okay.
Yeah. And his stuff is all happening in April, and so it doesn't really matter unless we could somehow magically move the finals week to a week later. Then he would like that. We can't move finals week a week later.
No, I understand that.
And technically, the way this that last exam will be administered is, in a technical sense, it's being administered on Monday, whatever that Monday is, of finals week. But that's just, and because everything for me is open book and all that, I'll post it a week ahead of time. And if you don't want to do any work on it during dead week, you don't have to do any work on it during dead week. It just that you have to do it all on that Monday.
I'd rather do a dead week and get it done.
Yeah.
Yeah.
Well, that's up to you. I can't. Technically, I can't I can't force you to work on anything during dead week.
Sure.
It's up to you to decide if you want to work on it during dead week. Otherwise, it's just you have 1 day to do it.
So the week of the 29th is a dead week, or the week of the 6th?
Week of the 6th is final week.
Week of the 6th, okay.
Yeah, week of the 29th is dead week.
Gotcha.
Okay, and then our final would be due the first day of final week.
Yep. I think I said it in the announcement. I said something about we'll cover a little more material if we only have 1 exam left. Meaning we'll spend more time in class talking about things instead of taking an exam during that one of these intervening weeks.
Mhm. Yeah, that's actually what I was going to ask you about, and I'm glad you brought that up. Is for what? I know that technically we could probably talk about lots of stuff, but is there anything at this point that we'd be important that we'd be missing out on if we took 2 exams instead of 1? Something that
It wouldn't be as thorough. We wouldn't spend as much time on selection and response to selection. And the other piece of that is that breeders really end up selecting multiple traits at a time, so we would miss out on the concepts of selection indices or independent culling, and we just wouldn't spend as much time with those issues. And we probably wouldn't spend as much time with genomic selection and how genomic selection is being implemented for multiple traits, that sort of thing. They're just little details here and there that we probably would never cover.
Yeah, it's hard to. I mean, you always want to get more out of the class, but on the other hand, it's April.
Right. Yeah.
Both as the end of the semester, but also planting is starting. I think you mentioned that in lecture yesterday. It's going to start getting busier too. So. Yeah.
Well, around here it's very busy right now. All the students are spending all their time putting up seed and laying out their field plots and doing just all that stuff, getting ready so that as soon as it's warm enough, as soon as the soil's warm enough and dry enough, they'll be out the door.
Mm-hmm. Yep.
Yep.
So for ALA 14 question 3, would we be looking at different sample IDs or specific lines of data?
LA 14, question 3 says, for data of high quality, estimate variability on an entry mean basis. Is that what you're asking?
Yeah.
So what was the question?
So would we be looking at like the different sample IDs or just specific lines of data?
I suppose that has something to do with the data set that you're asking. I'm not following entirely. Let me look at the data set. Is that what you're talking about?
Yeah. Sorry, I was talking about the data set.
Oh, okay.
Yeah, so it's like each sample, the entry number.
Yeah, that's right. Under the column says sample, and those are, remember, we get a population, we get a bag full of seed, and from that bag full of seed, we have plants, and there's 103 of these plants that flower at the same time as the tester. I don't, the total number of plants that were planted is much more than that, but these 103 happen to flower at the same time as the tester. And the tester's adapted to the environment. And so these just represent individual plants out of that bag of seed. And so sample number 1 is just plant number 1, right? And plant number 1 was grown in 60 plots.
Yeah.
Or its test cross seed was grown in 60 plots. Now, is that helping to answer that?
Kind of. So we would just take the average of the yield over those 60 different
Yeah.
sites to look closer at them and figure out what our heritability estimate is.
Yeah, so that's right. So each of these samples is gonna represent an entry. And so you could have an entry mean for each of these individual plants. And you sort of have to recognize that we're not selecting any of these plants. We can't do that. We're under obligation to destroy these things. You know, what we want to do is know something about the genetic variants of this popcorn, and we'd like to know something about, you know, how is it going to add useful genetic variability to the system that we already have, and our system that we already have, we have a couple of and how big is that additive genetic variance going to be? So I guess there's 500 kernels we took out of the bag, and we get 100 and some. And what we want to know is, we'd like to say, wow, this stuff has got, some pretty, or maybe it doesn't. Maybe there's, the additive genetic variance and the heritability on this stuff is, not that wonderful. And so what we want to, so basically what we want to do is just ask questions about the additive genetic variance among these individuals.
Okay. So then in the next question 4, when it asks us if the estimate provides broad sense or narrow sense heritability, is that more like a theory discussion question where it's interpreting what that entry mean basis means?
Yeah. Well, you're going to have entry means, but are you going to be able to get estimates of additive genetic variance from those entry means? That has to do with, is there any known covariance relationships among these 100 plants?
So since we made test crosses with a known tester, then we probably could figure out some covariance.
Well, yeah, they're all related to each other through the tester. That's true. The tester is like it's like a common parent. In this case, it's a common female parent. But that's, I don't really care about the covariance among half sieves based on that tester. I want to know the relationship among those seeds that I'm getting from the bag. Okay? Do I know anything about the seeds that I get out of the bag in terms of their relationship with each other?
So the half sieve values are just kind of too disconnected from the actual mixed OP bag, so that's not going to give you meaningful.
Yeah. Your test cross seed is certainly, they all have relationships among each other as half sieves, but I'm trying to draw inferences about the stuff in the bag in the seed bag, not about the test crosses. Because I may want to negotiate with the government of Guatemala and now buy this new source of popcorn.
That makes sense. I guess if you base it on the half sieve, they might all look promising, but it might just be because you have a really good tester.
Well, yeah. The real issue is, can you figure out additive genetic variance?
Mm-hmm.
Yeah, that's the question. And then you sort of have to assume that this when they send out a kilogram bag of this land race, it's called an open pollinated land race, but that tells you something about the population dynamics. Would you expect these this to be in Hardy-Weinberg equilibrium, for example?
Maybe.
Yeah. You could. I think you could make that assumption. You don't really. I mean, most land races. There might be selection going on among individual plants, but probably not. There's certainly no selection going on in the mating. They're just pollen's just flying. Okay, when it's time to pollinate.
They're self or cross pollinating. Well, probably not self. Mostly cross pollinating.
Yeah, most things are. Well, yeah, and so it depends on how much wind there is, and you end up self-pollinating or do you end up cross-pollinating.
So any pressure that might be on there is just natural selection, as they use the general term.
Yeah, right.
Yeah, and it's probably like a quote-unquote infinitely huge mating population.
Right, yeah. It's not infinite, but it's
Well, yeah, but
bigger than we can count.
yes. Bigger than anyone wants the job of trying to count.
Right, yeah.
Okay, that makes sense. So once we figure that out, the confidence intervals on the predictive values would be like a new set of calculations based on our means then?
Well, you know how to calculate confidence intervals. You need some kind of estimate of the standard deviation. And once you've got that, you convert that to a standard error based on the number of observations. And then you have some sort of confidence interval. So it's just the way you've always, or the way you did confidence intervals in introductory, the introductory statistics type class.
Oh yeah, I'm sure I can figure it out. It's funny how we like keep doing these increasingly complicated things, and it's like do this simple thing, and it's like, oh, I don't know how to do that anymore.
Yeah, right. Yeah, yeah. But yeah, it's like CVs. In the class discussion yesterday, I guess it was. Those poor three guys sitting in the classroom, they just had blank looks on their faces. Like, we're not asking that. It's something so simple, are you? Really? You just want to know what a CV is? Yeah, that's all I wanted.
Yeah, this
That was pretty funny. You stumped me too while I was watching it. I'm like, wait a minute, no, it can't be that simple.
Yeah, right.
Yeah, well, this assignment doesn't seem really awful then. Like, I guess that this could probably be done like today and tomorrow.
Yeah, it'll be done pretty quick. I'm not sure. I think ALA 15 will take a little more effort.
Yeah, it's got a lot more questions.
A lot more questions, but I don't remember it being conceptually real difficult. But it's going to take a while to, use Excel to simulate these things. And I'm in class. I think I'm going to go over ALA 6. I think I'm going to do it tomorrow, and point out where you have to be careful when you're simulating as you go from one environment to the next, or in this case, from one family to the next. So that if we redo that, and there's some location things, but those were some of the things that kind of stumped people on ALA 6. So tomorrow I hope to review that, unless there's something we get snarled up in something else. in the class presentation tomorrow.
Okay.
I think I mentioned it, but I'm going to be on the West Coast in, let's see, on the 12th and the 15th. So I'll be doing the class. So on the 11th, I won't be able to check in for our office hour, because that's about the time that the plane leaves. So on the 11th, Thursday, the 11th, and then on Tuesday, whatever day that is, those are travel days for me. So I won't be able to join you guys on the office hours on those 2 days.
Are we still going to have a class lecture on Friday?
Yeah, I'm going to try.
Okay.
We'll see. Last time when we first started this class, I was on the West Coast.
Mm-hmm. Mm-hmm.
And it seemed to work out okay. So we'll see what happens. I got a new, I'm going to be at a different connection, and hopefully it works, but we'll see.
Yeah, and I'll be down in Ames next Wednesday for my defense in the morning. So
Oh.
I don't know if I have the chance. Maybe I'll sit in class and make it 4 in the room.
Oh, all right. All right, good.
We'll see how brave I am.
Yeah. What time is your defense?
8:30 in the morning.
Oh, gee. Oh, well. So you're going to get up at 3 a.m. and drive down? Is that?
Oh no, I'm coming down Tuesday afternoon. Oh yeah, I'm not. No, I'm not. It would. I'd have to leave at like 2 in the morning because it's about 6 hours of driving. Yeah.
Okay.
Yeah, but if it wraps up, I'm just not sure how long the whole defense takes. Start at 8:30. If I'm done by 11:30, I don't see why I couldn't make it to the classroom.
Yeah, you should probably be done in an hour or two.
Yeah. And then it depends on if I need to drive all the way home any sooner, that kind of stuff.
Yeah. Yeah, weather, you have to watch the weather.
Well, that, and like I said, 6 hours of driving, sometimes you want to hit the road as early as possible.
Yeah, absolutely.
So.
Well, I look forward to meeting you, Chuck, in face to face.
Yeah, I'll definitely try and stop by. Yeah. Yeah, so far as questions, ALA 14 seems pretty straightforward. And 15, it looks like we're going to have another, you're going to have to cover more in lecture before we're really going to be able to dig into it. So I don't have any other questions.
Okay. Very good. I'll let you all go then. Unless there's somebody else who has a question. Okay.
I think good for now.
Yeah, thanks.
Thank
All right.
you.
Sure. Bye-bye.
Thanks.
Yay, he answered our first question for us.
Mm-hmm. I tried to just slowly extract as much as I could.
You are good at that.
Sometimes.
Oh, no, that worked well.
Mm-hmm. Yeah, I think we have the makings that if we hunkered down, we could have most of this done. Well, yeah.
Well, I already started doing the R stuff for question 2.
No.
I started. I haven't gotten anywhere yet.
Real quick, for the first one, he was saying to do it. You're still just doing that one season. You're not having an extra season for it.
I think so. Just, yeah.
Okay.
Oh, you mean for ALA 14?
Yeah.
Yeah, you just get one shot at this, is what he's saying.
Yeah, because it says you can't do any breeding on it, so you're just making your test cross seed. So.
Yep.
Okay.
So it's kind of all or nothing.
Yep.
Now, I'm sorry, Cassandra, I didn't hear your discussion with him about the kind of in the middle there. What questions did you ask him for information on? I could hear you typing out notes.
Yeah, started at like question 3.
Okay.
I could just share the, like, I don't know if they'll mean anything to another human being, but I could.
Well, it says on an entry mean basis, and I was wondering. He was saying basically some of them might be of usable.
Yeah, it's just like, so you have like 60 samples that are ultimately all from the same GE. So you're just going to sum those up. It's like almost like if you had 60 sites that you tested a line at. But it's not a line, technically. So, does this mean that, how many samples are there?
There's 105. 2 are the the best hybrids.
Oh, yes.
So
Okay, so we're going to do 103 by 60 test crosses.
wait, are you talking about question 1 or?
Question 1.
Okay.
You're going to do, well, from what he was intimating, here's what I'm getting. 1 ear of corn will produce 300 kernels.
Mm-hmm.
Each plot will use roughly 110 seeds. And we have to pack them, each one, into 60 plots. So you need 60 times 110 divided by 300. You need to do 22, roughly 22 crosses per plant, per landrace plant. So you have to have 22 test cross plants per single landrace plant. Does that make sense?
Yeah, 22 crosses per land raised plant. So
Yep.
if we're doing that, then we have 22 by 103 crosses
Yep.
total.
Yep, so 2266. And I have no idea, is that reasonable for corn? I'm assuming so.
You better have lots of help.
Kind of a lot for one plant to pollinate.
Yeah, like that's a lot.
How much
He
did
was
you?
saying-
How much did you say?
22 per plant. 20. So one landrace
22
plant.
plants per line.
Yeah. Well, okay, so you have one landrace plant of each of the 103.
Hmm.
You need to pollinate 22 test cross plants, that one plant. And he was saying you'll have more than enough pollen to do that, so.
If you have a good day.
Yeah.
Well, that's how he put it. You can
Yeah,
assume that.
I guess we're assuming it's perfect conditions.
Yeah. It's not too hot. It's not too cool. It's not windy. It didn't rain.
And I will tell you right now, I ran a box plot, and there are a few of these. I mean, they're all reasonable, but there are a few of these that are better than the testers, so barely.
Oh, did we account for double rows per plot?
If you're doing 100 to 110 seeds, you definitely are, because
Oh.
like for our plots, we do a 17 and a half foot. We fill at 85K, and then we really only want in the two rows we only want 66 plants, and that's about a little over 3 or 4. It's between 3 and 4 inches spacing between plants. So my
So
estimate would be lower than what he said.
So 100 seeds per 2-row plot?
Yeah, that's definitely plenty.
Okay, well then.
And I mean, you could play with if you're gonna specify your length or anything, but he said
Right.
like a 10-foot plot and 100 seeds for 20 feet is gonna be very, very tight.
Yeah, no, that makes sense. I work with small seeds, so
Yeah.
Well, if you have a better number, you can definitely say based on, if 80 seeds per 2-row plot is more reasonable, 40 seeds per row, is that?
I think the big thing for this is just giving good reasoning as to what we would do. And
Yeah.
and then get caught up in the specific numbers.
Yeah.
Well, I need the specific numbers. I need them.
I'm going with closer to that 80 number.
You're going to go with 80?
Yeah. Because I think 100 seems like a lot. But,
Yeah.
or 110. And then you can get fewer plants because I know you can carry, like if you have very good pollen, like yes, you can pollinate multiple plants, but 22 still seems like a lot of plants to pollinate from one male plant.
Yeah.
But I mean, you can have pollen multiple days, but I generally wouldn't carry to more than 4, and that's probably pushing it for me. I mean, I just like having good pollen though, like a nice amount. I mean, you can stretch it thin, but
So I think when I did it, we would do like.
Well, if we can, okay, here's the numbers then. If we can do 300 kernels per head, if we're going to do 80 seeds per 2-row plot, and you have to do 60 different plots, then now by doing that, it's down to
4,800.
it's down to 16 test cross plants per single landrace plant that you have to get pollen from. Is 16 a little more reasonable?
Yeah.
I mean, obviously it's a lower number. I mean, you're talking 6 fewer plants per cross, but
Well, he mentioned we could go both ways as well, didn't he? Where you take the landrace to the tester and then the tester to the landrace.
yeah, he did say that. But he said we shouldn't have to.
Yeah, because I mean, really, if you only have one plant per 103 lines, then you'd only get one more plant, right?
Yep. But all I'm saying is that as long as you think you can get the 16 from one, that's fine.
Oh, so he's okay. So let's set up where there's one tester per landrace. I see.
So I think the only question that I still have is why are we only assuming one plant per? Because if we have 500 kernels,
Yeah, but he's
couldn't-
saying only 103 of those flower at the same time as the test.
as everything else,
Yep,
Yes.
and so
Yeah.
each individual is being treated
as
as
all
an
of
individual.
them.
Yep.
Okay, that makes sense.
Yeah, I'm a purity thing.
Yeah, so then I pretty much have to go with that.
there.
Oh, well, when you do your ANOVA, don't be too hasty.
Why?
Because it takes it a little while to go through all the data.
Oh, it's got 6,000 or whatever.
Yeah, well, I was being kind of pushy. Oops. Oh, cool. Well, at least I got it set up right. It looks like my degrees of freedom are all good. And to make life a million times easier for everybody, because I'm just such a nice guy, I will take all of my work and post it.
Yeah, code?
Yep. Because I got to go eat supper so you guys can all dive in while I'm doing it. And the coding may seem a little weird, but meaning I'm just copying and pasting a lot of it from other assignments. That makes sense. So there you go. You guys check it out. I'm gonna jump off here and go eat, and we'll see if we match up.
Sounds good.
All right.
Are you guys bringing up like box plots and whatnot right now?
I am.
Yeah, just finish.
Well, I was looking at it, and so like one of the ones that Jacques had was yield by environment, and then it goes 1 through 6. But
There's like
there's 10 cooperators, and there's 6 environments for each cooperator. Would that really be accurate? Because field 1 for cooperator 1 is going to be different than field 1 for cooperator 2.
So he has both. He had done both by environment and by cooperator, though, right? So the cooperator one breaks that out.
I guess I just don't know if we'd want to.
If you really want to use the other one at all.
Yeah.
Yeah.
Try the other one now.
Yeah, I skipped the field as well. I did cooperator and line.
So did you guys already do the yield by line box plot?
Yeah, it's terrifying.
So what did you guys put in for your AB line? Or did you put one in?
I have mine in for 60. That was what Jacques did. And I am not sure why that would have arbitrarily been assigned, other than that, like, there, because it's, yeah, the average yield. So I think that might be,
I think 60
have it there at 60.
I think 60 was from a previous assignment.
Yeah, because I was going to say the average yield I have is 110 is what I put in.
Did you get that from the 2 for the overall or for the 2 best hybrids?
Just overall, I guess.
And I did the hybrids, and that was 118.
That makes sense.
The average of lines 104 and 105 is 118.
Yeah, I might put both in.
Yeah, cooperators looks like we have a pretty clear split.
Yeah.
Zach, you said you had 118 for the 2 hybrids.
Yeah, I took them both as one, and it was 118.
Okay.
I didn't split them up. I did the average over both of them.
Always worried I'm missing something.
right, I'm back. So you guys got it all figured out, right?
We're on ALA 15.
All right, awesome.
I'm just kidding.
Yeah. So did
So
you
I
just
think-
figure anything interesting out?
I think the model, I think I have the model to use for the linear model. And then did you do the box plots for yield by line and yield by cooperator?
Yep, I did all the code I gave you is what I already ran before I left.
Oh, you didn't? Okay, gotcha.
So I got the LS means for each of the samples and all that stuff.
Let me see your coding.
The only thing that doesn't have significance is sample by cooperator, which is technically sample by region. I think the cooperators are the regions.
So you got yield line, cooperator, line by field.
Yeah, it says cooperator on there, but in the explanation, it's the region. So cooperator and region
Sure.
go hand in hand, and 6 sites.
Yeah, yep, that's what I got. Yeah, line by cooperator is not significant.
Yep,
And then ANOVA results.
yep.
And then you did line, and then I did the LS means for cooperator as well.
Oh, okay.
Then you can see which cooperator is better, which follows the
Well, technically, it's which environment is better, but gotcha.
Yep.
Could be a little bit of both.
All right, so. So, what do you have for a linear model, Zach? I've got yield, obviously, as my cooperator, and then we don't have to use a mixed linear model, do we? Because we have it's all balanced, isn't it?
Yeah, I don't think
Everything was
we need
balanced.
to.
I think that the ANOVA is all we need.
They all have, yeah, they all have the same, number of fields, and yep.
So you can run, did you rerun the ANOVA without the sample by cooperator then? Since it's not significant, and then you I don't know, I mean, that's the question. Do you keep it or do you not, and then throw it in the residuals or not?
Yeah, I can show that.
I'm just wondering what your thoughts are on it, that's all.
No, yeah, you should throw it out, definitely. Yep.
Okay.
Yeah, that gives us this guy. Yep, 10495.
What? Not about it. No. Good. Good job, Ernie. Yes, I think one of the boys started.
Okay, looks good. Did you go into the data set and change the?
Yeah, I changed my header so they matched up a little better with the code I had already, but
All right.
a little bit, I guess.
So, you got 4 low and 6 above
That looks like what I got too.
for the box plot. Huh?
Yep, this is the operator. Yep.
Let me take a look real quick.
And you had the AB line set at 60. You may want to change that. You can choose what you want it to be at.
I did, yeah. I'm sorry, I threw that code in there. I gave you the code and left, and then I was like, oh, I forgot to mention a bunch of stuff. Yeah, the AB lines were left over. They're remnants from previous stuff.
Sure.
I didn't know so what did you guys figure out the AB line should be?
I did 118, which is the average yield of the 2 hybrids at the end.
Okay, 118 for yield, just yield?
It's those two hybrids that are lines 104 and 105. I just averaged the yield of those.
Yield by cooperator, okay, gotcha. 118?
118 was the average yield of the two hybrids, yep. But someone else mentioned that they took, I think it was 110 is the average yield over the whole data set. So, probably a couple different ways to skin it.
Okay, yeah, I got exactly the way that you. So, looking at yours, you want to go back to that previous one?
Yep.
Oh, yeah, same thing that you got. Why don't you have any color?
I don't know. Don't want it. It's just extra code that I can mess up.
Okay. So, what is this telling you?
So similar to the other summit, you have 4 cooperators that are averaging less yields than the other 6.
Yeah. So, what do we? I know this looks exactly like the data set that we got at the very beginning of this class. Does this mean that they got planted late, or?
I don't think we have to worry about maturity because they all.
I'm just asking. We don't have maturity to check it against.
Yeah. So let's see, what's next? More EDA stuff.
Sorry, I was trying to talk and I was muted. Do you have that just sample and cooperator are significant?
No, so if you expand it out a little farther, you get line by field, or sample by field is significant as well.
Okay.
And that's on my screen right now if you want to check it out.
Yeah, because I've got sample is significant, field significant, cooperator is significant, and then sample by field.
Yep.
So 4 of them total.
Yeah, sample and cooperator was the only thing I had that was not significant.
Yep. And then, so I'm going to throw that out.
Oh, how did that work again? He doesn't want us to report it if it's not significant in the ANOVA? Or can you report it and just say it's not significant?
Right, it shouldn't be part of your model if it's not significant.
Oh, yes. It's been slightly too many weeks, apparently.
And you said 118 is the average of the 2 tester lines. There we go. Yep.
The 104, yeah.
I did the histogram, now I put the line in there, so.
What do we need for this?
I'm not sure about using field since, like I was saying earlier, you have field 1 for cooperator 1 and field 1 for cooperator 2. They both say field 1, but they're different fields. Would you want to include that? Because it's going to be misleading.
Ooh, that's a good point.
I feel like you'd care more about sample and cooperator in that case.
Yeah, I didn't include the others.
And why are we creating the linear model?
We're not.
Okay, we're not. Sorry, I thought that's what you guys were working.
If I'm reading this right, we do not want to do yield by environment. Six sites, 10 regions. Yeah, yield by environment, because actually it's not the same environment or site in each of the different regions. It's all different, so you can't really glump them together.
Yeah.
So that's not going to do any good. Because, like was said, field 1 in environment 1 is not the same as field 1 in environment 2. They're not.
Yeah, but couldn't the same thing be said about reps? Like if you have multiple reps in one field?
But this is saying like you have, I mean, because you really have 60 different fields. But if you look at numbers one, the way the file is, it makes it look like there's 6 fields. So that'd be different than.
But like if just to look at it a different way, could you say that that's 6 reps within one cooperator?
Yes.
Yeah.
So then line by rep could still be important, right?
I don't know.
Well,
I don't know. I'll keep thinking about it. I don't know. It's talking. I think your favorite words. That's literally all you can do. That's why you chose this thing.
And remind me what making everything fixed does. Does that get rid of that issue that we're trying to figure out?
Yes, because it makes it, or it changes it from like a calculatable value just into like a category.
Sure. Okay.
The factoring.
The words, but yeah, just so it's not a continuous variable that it's going to try and like make numbers out of.
So Emily, maybe that would take care of the issue.
yeah, I mean, I always do, or I have that done. I guess I'm just thinking of it.
Well, the factoring is what helps out when you run your ANOVA, so you get your degrees of freedom correct.
But you're basically saying that you're thinking we don't need to do the yield by like the 6 sites, because the 6 sites really include all the 10 regions, right?
Yeah.
Yeah, because you have 1 through 6 for each of the 10 regions. So if you like looking at those 6 reps basically is accounting for 10 different regions, which doesn't seem right. I think the yield by cooperator fits better. Like if you could do it so that you would break out like the 6 reps within that region, that would make sense. And look at the like 60 different, but
you'd have to basically add a line of code in there to break it down.
yeah.
And the question is, do we care?
I feel like we don't.
Right, so we could just get rid of field and line by field as well in our ANOVA because we don't care, because they don't really match up.
Well, and that's like, if it is being equated to rep, a lot of the times he says don't include that, or it gets taken out.
Yeah, because we worry about the sample, which are the lines. So we want to know how they did. And we're worried about the cooperator because technically that's the region.
Yeah.
But the field, in both the field and the sample by field don't matter because there are 60 different fields, not 6 different fields. And if you look at the degrees of freedom, it's treating them as if they're 6 different fields.
Yeah.
If you really wanted to break them out separately, you'd have to go in and renumber them. But then again, what information are we going to get from it? Are we going to grow one popcorn? I mean, we're not trying to figure out which line to grow in which particular specific site in which environment. We want to get it across all the environments, right?
Yeah.
Just my thoughts.
Yeah, I can't remember if we ran line by rep in previous assignments and then found that it wasn't significant, or if we just never even cared about it.
It depends on the data.
I'm probably just confusing everybody.
Well, what I'm saying is I think with the first, we could look back, but I think the first data set, he had it set up to where he was telling us, the reps within, we had to figure that out. We could nest them. Does that sound right?
Yeah, I can try that.
Yeah.
Nest the fields inside the. What's the code for that? That I don't remember.
That you use colon?
Colon, yeah. Yep.
Okay, wait.
Sit down. No.
Does yours show that you have 50
No, wait. No.
for that? So when I did field colon cooperator, I added that, and my degrees of freedom is 50. Is that what you have?
Yeah,
I
40,
don't have,
45.
Yeah, I've got 45.
I'm still running mine.
And it's not significant.
Mine shows that it is. That makes no sense.
What's your code?
No.
All right.
This is what I put my code in the box or group chat.
I did mine as sample by field, so that each field is run on its own, and I got 525 degrees of freedom. Because your field by cooperator is just going to give you each field within the region. Remember, your cooperator is your region. You have 10 fields in each region. So, do you need to know that should give you your variability of yield within each region? Do you need to know that, or are you already getting that with the box plot that Zach has up right now? That makes sense? You guys following what I'm saying?
Yeah.
In my code, I did sample by field, which would give me the line in each field, the significance, if we want to pursue that, and I'm not sure we do. Maybe it's I don't know, sample by, no.
Emily, try putting in sample by sample time field at equation as well. Will that change your degrees of freedom?
Ooh, it does not like nesting.
Don't. Oh. No, it didn't. I don't understand. But when I did sample by field, it. Oh, wait. I think I know what I did. No. Everything else matches. I don't understand how that's not.
Well, what is it? What is the significance of having 6? I'll make sure I get this vocab right. 6 sites in each of 10 regions. Isn't that just replication?
Yeah.
Okay, so then we know that each region is well represented, right?
Yeah.
So do we need to worry about the sites? Those replications individually, or are they just, is it good enough to have the regions represent?
I feel like the region is a better representation because, like, right now, if you just do field, like, it's lumping everything together, right? So
Yeah.
site 1, even though it's at 10 different regions, like, you know there's going to be variation in that, but it's not really what you're looking for, right?
Yeah. Because if you just break it down and you just have sample cooperator and then sample by cooperator, that's kind of what I'm thinking should be enough information, right?
Is your sample by cooperator significant?
I'm running it right now.
Okay.
It shouldn't be, I don't think.
The sample by should, but it's not. You're right. Sample by cooperator is not significant.
Yeah, that's what I had.
So sample by region isn't significant, but we have a box plot that says it is.
So I do know why I was getting 50 degrees of freedom for field nested into cooperator, because I didn't include field as it's separate.
Oh.
I just, yeah.
Oh, sure.
But that's
So
not.
based on this, should we just be doing sample and cooperator and that's it?
I think so.
Well, I'll post mine on the discussion board to see if anybody picks it apart.
Yeah, I mean, I still feel like from that box plot, though, I mean, it should say it's significant, right?
Mm-hmm.
Because
Well,
you can
that's what
definitely
I'm
see
wondering.
it.
Well, the histogram shows, let's just go over the basic stuff. The histogram shows that there's definitely crosses that are better than the testers. More than one. Yield by line, which is the nice box plot, shows that there's definitely lines that do it generally as well as the testers, but I don't know if I'd say there are any that are significantly better than the testers. Unless somebody saw something in that particular, that beginning. And then we did the yield by region, and in that's when we saw that 4 regions are different than 6 other ones. But the overall yield between them isn't. Now, that's the thing, is that 4 of them should be different from the other 6. There should be a significant difference by region. And by cooperator, and we do see that there's significant difference in the ANOVA from that. So at this point, we don't do field because field doesn't matter. So then, based on that, I wonder if this isn't one of those things to where he did it and we're going to find out that nothing matters. In other words, none of them are good enough, and so we don't want to deal with it. That'd figure.
Should we start looking at question 3 or?
Yeah, we might as well wait until there's some feedback on what to do with that linear model and what people are thinking.
Yeah, I just posted it.
Or data that are of high quality estimate heritability on an entry mean basis. So each sample is an entry that can be grouped together, was what I got from what he said.
Yeah, that's what I took away. So do we want to use LS means for this to determine those that are of high quality?
Yeah, I guess that's the first step. It's like, what's a high quality line? There's 160 of them, or no, not 160, 103.
So how are we estimating what data are high quality?
Would we want to take those that are all above the overall average for yield?
So are you just hand calculating the mean by line for each 60?
I just put the LS means into my Excel file, and I'm just looking at that. That would give 62 lines, including the 2 hybrids.
Cutting it in half seems reasonable.
Well, yeah, but the point is what's significant? Meaning, you want to have you're going to be negotiating for just a second here. How do I do that again? Merge and center? No. Okay, I just put the data in the Excel file and then I do what? Data?
Text
to
columns.
That's the columns, yep.
Thank you. So what I'm saying is if we're going to negotiate with the government to get, a bag of seed that may cost a lot of money, it's got to be worth something to us significantly, not just generally. So I'm wondering what that would, what signifies that to you guys?
Well, the only data we really have is the yield.
Yep.
So it kind of, I don't know, I guess limits.
Do we need the upper and lower CL confidence limits? Do you think? Standard error is the same for all of them, it looks like. So what I'm getting at is, okay, so 118 and 119, so technically 118 and a half, if you want to average between the two test cross lines, the two parents or whatever that you're going against, how much more on top of that for average do you think would be necessary to make you want to pursue this?
Well, there's only 2 lines that are above that 118, 119.
I guess I go with the higher one, 119.
So I'm backpedaling a little. What did you guys ultimately put in for your LS means? Just like, is it?
Like in R?
Yeah.
I just put it,
It's, yes.
ah, shit.
Can you do a greater than function for count if, or what are you using to find the lines that are better than 119?
You should be able to filter for greater than.
Yeah. Or you can sort it high to low.
Yeah, just sort the column.
All right.
That's-
Yeah, make it simple. Make me feel stupid.
But, yeah, there's only 2 that are equal to or greater than 119.
Which one's, I got line 9076. Is that where you're at?
Yep.
Yeah.
So I guess my point right now is specifically that if 104 and 105 are our 2 testers that we have to do better than, and all we need is, if we're looking for just genetic variation, okay, I understand that, but
Cassandra, I put my code in the chat if you didn't see it.
I see it right now. Yeah, so I did.
I don't know if that's...
Yeah. Okay. I think I'm getting the same numbers as you guys, even though I didn't quite run the same thing. But yeah, it was like the 2 that Zach said were bigger, and then the Ford 105 are higher. But are they the hybrids?
I'm just going by what he has written up in here, is that the yields do not seem to be increasing as fast as they did for the previous breeder. This land race, you've just got something where the yields are just as good as your test crosses, or your not test crosses, your 2 best hybrids.
Yeah, like nothing's better.
Yeah, exactly. So if it's not better, would you want to spend money to get something that isn't any better?
But it could have other qualities that when crossed with...
Well, remember, that's with the crosses with your best
Oh, that's true.
test cross. You did the test cross, and this is the best you got out of that for the F1.
Well, and I think that's where the later questions will come in, where it's like, can you prove that there's additive genes in this without doing markers or breeding technically? So like,
Yeah, he was kind of getting at that with today's lecture, going with the CV and the average yield. How do we calculate the CV? Maybe I should ask that.
Oh, we should know that one after Monday's lecture.
I don't remember how to calculate it. I just remember that we had that the CV's there. It's because the question that I have is, do you want the mean of your what do you want to use as your mean? Either your 2 best hybrids that you're comparing it to, or across all of the hybrids, or do you do a CV for each line? I suppose it's each line, isn't it? My brain's not attached today, I'm telling you. Sorry guys, my brain's out.
Estimate heritability with this.
Okay, so yeah, like we have to like sum down to which ones were actually what we think is high quality data
So
and estimate heritability on an entry by mean basis.
The coefficient of variation. Okay.
I have not been paying enough attention.
Don't feel bad. I've been trying to pay attention and I still feel stupid.
Yeah, I haven't watched yesterday's lecture either.
Next.
Is it
Small case heritability is the little o with the tail squared of the genotype divided by phenotype.
wait, which Oh, I have the wrong one open.
Yeah, like these ones will be probably just in Fair's book.
Oh, here it is. Page 17 of the variance, covariance, and heritability note. A type of heritability estimate referred to as an entry-mean basis can be estimated as, and then it's h squared equals a ton of stuff. So are we supposed to do this in R?
I think you could just calculate it in Excel, but maybe not.
Yeah, so it's O, or not O. Oh my god, I feel so stupid. Whatever the symbol. Is anybody else looking at this?
Yeah, I see it.
Okay. Yeah, it's really not that difficult if you just not sure what we're supposed to divide by what.
Hey guys, I'm gonna grab some dinner and get caught up. Hopefully I can be more help on Thursday then.
Are you taking out for the whole night then, Zach?
Yeah, I'm kind of I need to look at these notes, obviously, I think, so.
Yeah, he covered some stuff in the lecture today, or yesterday, that I think might be useful for figuring this out, and I just don't recall it off the top of my head.
Okay. Yeah.
Did anybody else watch the lecture from yesterday that...
Yeah, he talks about the A and D.
Right, and then he boils it all down to a lot of simpler stuff. I just don't remember H squared, as in the heritability estimate, being one of them, but I might be wrong.
Well, I think we just need to figure out A and D.
Yeah, because I think that 3 is what it is estimates for a particular set of F2s, but we're not dealing with F2s, we're dealing with F1s.
Where are you seeing that?
What do you mean the on page 17, limitations of this method?
Okay.
But it doesn't matter. We're dealing with... This is broad sense heritability.
Okay, I was still looking at the top. Couple pages.
I'm still stuck on question 2, so. Generate a brief report on the data quality. Nothing is better than my hybrids. I mean, that's the message that I'm getting out of this.
Doesn't look great.
But there's also nothing that's really, I don't know, a lot worse than everything else.
Yeah.
Well, I mean, the point that I'm getting at is this. We're going to have to pay money to get this new land race. So we're going to have to justify the expense of getting it. And we can't say, well, it's going to offer us greater yield because it doesn't show greater yield as hybrids. So with that in mind,
Since we made test crosses with our known variety and we weren't seeing any heterosis noticeably in those test crosses, that's concerning, I think.
But the LS means that we have are just the means by the lines, not by the region. You know what I mean? If we could break down the LS means by the regions, maybe because we're looking at the histogram, something in there has some pretty impressive yields, but we're not seeing it overall.
Yeah.
So I get the feeling we're supposed to do more than just generate the LS means and go from that. I think we're supposed to do something else. And I don't know what that is.
For Q2, I think that we do more analysis in the preceding questions.
Do you think maybe we need to limit it and look at, when he's talking about quality data, maybe it's that we should be looking at cooperators 5 through 10 and remove cooperators 1 through 4.
That would make sense if, step 1, we have all of these different cooperators for regions. Whose data do we want to keep?
Yeah, because it's very clear that 5 through 10.
Okay, I'm looking at the box plots.
Yeah, I'm looking at the box plot right now too.
Yield by line. And some of them have some fairly significant variation or variability, range, whatever. The dotted lines.
Mm-hmm.
But so do the the two control hybrids.
And that would probably be because of the difference between the cooperators.
Sure, yeah, the 1 through 4. So if you could break it down.
So, but I think for question 3, I think we just need to, for data that are of high quality, I think we just need to say that we're going to use those top cooperators, so 5 through 10 rather than 1 through 4.
That makes sense.
Not necessarily eliminate some of the lines because overall they're performing about the same.
Okay.
Yeah.
Do we need to remove those cooperators? What I'm saying is are these, and this is something that's not in there, but are we looking for a variety or a hybrid that's going to work across all 10 environments, or in limited environments? You know, like he's asked us in the past.
Yeah.
And again, is this a problem to where the environments are actually different, or they got planted at different times? And we don't know that, but that might be something to put in the brief report. 4 of the environments are different than 6 of the other ones. Is this due to planting time? Is this due to a weather event? Is this due, you know, in other words, what don't we know? Just from this simple data. It's just bugging me that these things, that all these hybrids that we've made don't look any different from our 2 best hybrids in the program. Even though there's potential, there's also potential within our test hybrids too. So are we getting anything for our money for getting this new line?
So why don't we try running the LS means taking up the first 4 regions?
I think we also need to remember that, like, for 3, we're estimating heritability and we're not, our
Yep,
goal
yep,
isn't
yep.
necessarily to choose the top lines.
Yeah, I'm just bringing up, I think this is me prepping for question 6. I think we still need to do all the work, don't get me wrong. Figuring out how to do this, the heritability, is going to be key. I don't know how to do the confidence intervals, do you?
No.
No, but I'm sure it's a quick Google.
Oops.
Okay, one other thing, I just sorted the LS means data by the upper confidence limit too, and you don't get any change. But that might not be a good metric to go by. Sounds okay.
Welcome to WebEx. Press 1 to be connected. You are the first person to join the meeting. Please stand by.
The problem I'm having is I'm reading through the material and everything is dealing with genotypes. So how the heck do you compute Q and P with just yield data?
Hey, Bart, are you there? Right on.
Because I'm looking on page 13 and you got
Oh,
covariance of half sips, and I guess technically that's what this is. The tester is the common parent, as it were.
Yes.
And that's where it comes out to that weird, alpha, 1/4 alpha or something like that. I don't remember. I'd have to